And what is up everyone, welcome back to another VR tutorial. So we just got a new update for the Oculus integration, which now lets you directly test hand tracking inside Unity. Pretty cool features, right? And I want to test it out immediately with something that a lot of you ask, hand detection. So in this video I will show you how you can save a particular pose that you can later recognize to make some cool interaction. Anyway, without further ado, let's get started with the tutorial. Okay, so we are in an empty Unity project, and as you can see, I've already downloaded the new Oculus integration package from the asset store. Also, to save me some time, I've created a plane that I scale up and set it material to black to have a ground for little application. Now I will make a quick setup for using hand tracking. First, I will search for the OVR camera rig prefab and drag it in my project. Make sure that its position is at 0, 0, 0 so that it will be on the ground. Finally, set the tracking origin type of the OVR manager to floor level so that it will take the height of the player into account. And this prefab is what our player will use to see in VR, so I don't need the other camera anymore. Now, as you can see, if I press play, it's already working. We already have our VR game, and if at this stage you can't play the game, make sure that the Oculus Link is working properly and that your Oculus Quest is connected to your PC using a USB 3 cable. Okay, now next step, the hand. So the setup for hand tracking has a bit changed since the last tutorial I made, so be careful here. I will start by searching for the OVR and prefab in our project. We'll drag one under the left hand entry for our left hand and another one under the right hand entry for our right hand. As always, make sure that their position and rotation is at 0, 0, 0. Now with the OVR and prefab under the left hand entry, you can see that everything is already set up for this hand, so we don't have to do anything. But for the right hand, I will just switch the type parameters to hand right on the OVR hand, on the OVR skeleton and on the OVR mesh. Okay, perfect, we can already test our game now. And here we go. As you can see, the hand tracking is working inside Unity, and by default it will use it if you don't touch your controllers. And I can move my fingers and the mesh will follow accordingly. How awesome is that? And as you can see, now that it works in Unity, we don't need to build our game each time we need to test it. For example, here if I want, I can tweak the look of my hand while playing. So instead of the basic black color given by the default materials of the hands, I can maybe change the shader to Oculus/hands transparent, which I really like, tweak the rim power and the color to make it look nicer. Okay, now that we have hand tracking that works, let's focus on the reason you click on this tutorial, gesture detection. So to detect the movement we made, I will create an empty game object that I will name gesture detection. Now on this game object, let's create a new script called gesture detector that will be able, as the name suggests, to detect our pose. Okay, so in this script we need to have a reference to the hand's finger data. To do so, I will create two new variables, one public OVR skeleton variable called skeleton, and a list of the OVR bones called finger bones that I will set to private because I don't want it to be seen in the editor. So here, the OVR bone is a little class that Oculus used to pass data on the finger. If we click on it while holding the control key, you can see that it actually has some info about the ID of the bones, its parent index, but more importantly, the transform variable which will give us the position of the bone. Now back to our script. I will set the fingers at the start of the game by calling fingers equals new list OVR bone skeleton.bones. So here what's happening is that I'm populating the list with all the bones that can be accessed inside the OVR skeleton script using .bones. Okay, now that we have a reference to the bones of our hand, we need a certain structure that will store the position of these bones when doing a gesture. So to create this, I will need a public structure that I will name gesture. By the way, if you want to know the difference between a structure like this and a class like the gesture recognizer, a structure is exactly like a class, but that has no function, so its sole purpose is to hold data. Now in this struct, I will need a public string variable called name, which will be the name of the pose, a public list vector 3 called finger data, which will hold the position data of the pose. And finally, I will create a particular event by first adding using Unity engine.events at the top of the script and adding a new public Unity event called unrecognized in our structure. Perfect, now that we have the data contained for our gesture, we can create a new list of them inside the gesture recognizer class. And here we go, now let's save and go back to Unity. So as you can see, the script has compiled, the OVR skeleton variable is showing, but not the list of gestures that we made. And the reason behind this is that we need to serialize our structure by adding at the stop system.serializable. Now let's save again and go back to Unity. And here you go, the gesture variable appears now. I can create a new one, give it a name, and set the position variable by hand. And we also have a little event in our structure. Awesome. But let's face it, if we had to set the gesture by hand, it would take us ages. So let me show you how we can save a new gesture super easily inside Unity and while we are playing. I will first create a new function called save. First, we'll need a new gesture with gesture g equals new gesture. We can give a name to it. In my case, I will call it new gesture. Now for the data of the finger, I will create a new list of vector3 called data. And to set it, I will go through all of the bones we have with a for each loop and add it to the list with data.add. Now here is an important part in the design of our script. So we have multiple ways that we could compare a gesture. We could compare using the local position of the bones, the local rotation, maybe both. Maybe we could check the flex of the finger or its distance. So as you understand by now, there are multiple ways to solve this problem, and I strongly advise to see what works the most for you. But in my personal opinion, what I found to work the most is to compare the position of the fingers according to the root of the hands. And thus, I will use as the data of my gesture skeleton.transform.inverse transform point bone.transform.position. And here what the inverse transform point does is giving me the value of the bone according to the root of the hand. So this will make it possible to trigger the same gesture if my hands move or rotate, which is exactly what I want. Finally, we can set the new gesture finger data to be our data and add this gesture to our list of gesture. Perfect, now that we can save the gesture, let's trigger it. In the update function, I will trigger this function with a key press like the space key by doing if input.getKeyDown keycode.space, and if it's the case, we save our gesture. Oh, by the way, maybe you will need the space key for other thing than this, so it's better to have a little public bool variable called debug mode set to true here, which will disable this feature if it's not true. Okay, now let's save our script and test what we've made. So first we need an OVR skeleton variable. In my case, I will select the one on the right hand. Also, I think we can fairly remove the gesture we made earlier as we will make a new one. Perfect, now let's click on the play button. Here we go, I can see my hands with hand trackings, and what I'm going to do is make a certain gesture with my right hand and press on the space key with my other hand. Sorry if you only have one arm, in this case maybe use your foot. And there you have it, we now have a new gesture. I will name this one thumbs up, and now we can do exactly the same for every gesture that you want. Perfect, we have now created our own gesture. Before leaving the play mode, make sure to save the component of the end gesture, otherwise it will lose everything we've made. So now we can finally leave play mode, right click in the component and pass the value we saved during play mode. And there we go, we now have all of gesture in our script. Okay, so that was to save the gesture, but now let's detect it. Back into the script, I will start by creating a new function called recognize that will give back the gesture it recognized. Now to compare our fingers with one of these gestures, I will need to go through all of our fingers and search for the gesture that looks the most like the gesture by comparing the distance that they have. So first I will need a gesture variable, current gesture equals new gesture. which will be the gesture that we will return. We also need the current minimal distance found, called min_sum_distance, initially set to the mathf.infinity, because we want this value to be the biggest possible so that it will be overwritten the first time. Now let's browse each gesture that we have to compare them. I will need for each gesture two variables, the sum distance, so the total distance of the ends, compared to the gesture, and a bool variable is discarded, which will tell me if we discard this pose. Now for each bone in our finger, let's compare them to the pose. So I will create a for loop that goes from 0 to the number of finger bones we have. Then I will get the current data of the bone with vector3 current data equals skeleton.transform.inverse transform point finger bones I the transform.position. Make sure it's the same thing that we did to save the data here. Now we can check the distance between the two with flow distance equals vector3.distance current data gesture.fingers data I. Now that we have the distance between the two bones for each finger, we can decide to discard it or not. So let me just create a new public float variable called threshold, initially set to 0.1. And if we go back to the recognize function and the distance that we calculated is greater than this threshold value, we can now discard this gesture, break the loop to stop recognize this pose because it's too far away from what we have now. But if the distance is not too far between the bones, yet we can keep on and add it to the sum of the distance. But if it's not discarded, we can find which gesture is the more likely, and to do this, we can, if we are not discarded and that this gesture has the smallest minimal distance, we can set the minimal sum distance to be this one and the current gesture to be the one we are using. Nice! Finally, once over, we can return the current gesture, which, as you can see, will either be the initial new gesture, if everything has been discarded, or the most probable gesture. Awesome. And here we go, now we have a function to recognize our pose, let's use it. So in the update function, I will start by checking if we recognize a gesture with gesture current gesture equals recognize. Now maybe we didn't recognize any because they were all discarded, so to check this I will create a bool called as recognize and check if we found something with current gesture dot equals new gesture. Okay, perfect. Now what I want to do is check if the current gesture wasn't used previously, so that we will trigger an event only when a new gesture will be found. To do this, I will first create a new gesture variable called previous gesture. We can set it initially to new gesture in the start function, and in the update function, if we recognize something and that the current gesture is not equals to the previous one, we have a new gesture recognized, which we can show in the console to test which one we are using with debug.log new gesture found plus current gesture.name, and then call the events, so current gesture.onRecognize.invoke. Finally, we can set the previous gesture to be the current one. Perfect, and there you have it. We have now everything to test our gesture correctly. Let's save and head back to Unity. And there you go, when I move you can see that the most probable gesture is triggered in the console window. But make sure to tweak correctly the threshold value here, because if the value is too big, it will always find something and never detect when no gesture are found. But if you set it too low, it will never find any gesture. So in my case, I found out that a value of 0.05 worked pretty well. Also, important note here, so our end recognition only works with one end, right? So to make it work with both ends, it's really simple. Just copy the script and paste it in the same game object and then drag the other OVR and prefab in the skeleton, and here we go. Now we have a detector for the left end and a detector for the right end. However, the same gesture won't work for both, so you will have to create the gesture for the left end like we did for the right end, okay? And there you have it! We can now create new gesture with both ends and use it to trigger some cool event. Now it's your turn to do everything you want with this. And in my case, I think I will just spawn a prefab according to what has been recognized. So I will quickly create another empty game object called spawner, place it in front of the player, and in this spawner I want a new script that I will also call spawner, and this script will be really simple. I will start by creating a new list of game objects called prefabs, and it will only have one function called spawn, which will take as a parameter an index. And now in this function we will instantiate the corresponding index in the list of prefab we have. Perfect, so that's it. Now for the object that I want to spawn, I have already made 3 prefabs, one rabbit, one guitar and a thumb up. And what I'm going to do is drag them in the list of game objects we now have made. And now what's left for me to do is trigger the correct prefab from the gesture. So I will go in the gesture recognizer. For the thumb up, add a new event that will spawn the correct prefab and do the same for the other 2. And there you have it, our custom and gesture recognizer is working and trigger correctly the good event. Awesome! And that will be all for today. I hope you enjoyed this tutorial as much as I did making it. As always, if you want to support my channel and have access to exclusive tutorial, come check out my Patreon and join all of these new people that did so in the previous weeks. Thank you for watching and helping the channels. You guys are amazing.